What if I told you that inside one of the most ordinary objects on your desk, a simple pencil, lies a material with the power to completely reshape our world? It sounds like science fiction, but it's a scientific reality. We take the world for granted, but the universe is endlessly surprising. Imagine taking a piece of graphite and peeling off a single layer, a layer so impossibly thin it's just one atom thick. That single sheet isn't just thinner graphite, it's an entirely new form of matter. The discovery wasn't dramatic, it was quiet curiosity and play. Scientists in Manchester used sticky tape to pull apart graphite layers over and over again. They were literally peeling back the layers of reality. Physics said a perfect 2D crystal couldn't exist, it should curl or tear. Yet there it was, a flat, stable lattice of atoms. To understand why this discovery is so profound, we need to think about what materials actually are. Almost everything you can touch and hold is a three-dimensional object. The atoms that make up a block of iron, a grain of sand, the water in a glass are arranged in a structure that has length, width, height. These atoms are bonded together in a vast, repeating crystal lattice that extends in all three directions. This is the world we know, the familiar, solid reality that we interact with every day. A two-dimensional material is a crystal. The story of graphene becomes even more astonishing when you compare it to another, more familiar form of carbon: diamond. Both materials are made of exactly the same thing. They are pure carbon. If you were to analyze their atomic composition, you would find nothing else, yet they could not be more different. A diamond is the hardest natural substance known to us. It is brilliant, transparent, an electrical insulator. Graphene, as we've seen, is flexible, also transparent, one of the best electrical conductors ever discovered. How can two materials, made from the very same atoms, have such wildly different personalities? The answer lies in one of the most fundamental principles of chemistry and physics: structure is everything. In a diamond, each carbon atom is bonded to 4 other carbon atoms. This forms an incredibly strong and rigid three-dimensional tetrahedral lattice. In graphene, each carbon atom is bonded to only 3 others. The electrons that are not used in these 3 bonds form a delocalized sea that can flow freely across the entire sheet. The discovery of graphene was like opening a door to a new room full of building blocks for technology. And it's not just graphene. Its two-dimensional relatives are proving to be just as exciting. We are now at the dawn of a flat revolution, where these ultra-thin materials are beginning to reshape our world from the ground up. Take molybdenum disulfide, or MoS2. In its three-dimensional form, it's a common industrial lubricant. But as a two-dimensional sheet, it becomes a fantastic semiconductor. This means it can be used to build transistors that are incredibly small and energy efficient, paving the way for computers that are faster and more powerful, all while consuming a fraction of the power. They can be used to create displays that you can roll up like a newspaper or fold into your pocket. Because they can store energy so efficiently, they promise to deliver batteries that charge in seconds instead of hours and last far longer. Wearable technology could become truly seamless, integrated into our clothing or even as temporary electronic tattoos on our skin, monitoring our health in real time. The universe, it seems, was just waiting for us to look closer.